with slope-intercept form and also finding the x and y intercepts of the equations algebraically by letting the x or the y be 0 depending on what we're trying to find. We're going to have two problems presented today. We're going to walk around and check your homework today. And then think over any questions that you have and looking at the other pair of word problems. This is Thank you. So I think we're starting with Julian, right? Yeah. So Julian's going to come up and do number 14. We'll put his page underneath the document camera here, and then he's just going to kind of explain what he did for number 14, which is I think the x and the y intercepts problem. Pull it out a little bit for you. Looks pretty good. You might need to pull it up a little bit. We'll see. Let's get the bottom part. All right, so just kind of talk about the problem and what you do, Julian, to solve it.
Alright, so problem number 14 gives you an equation, and they're looking for the x and y intercept of this equation. And they give you 2x minus 3y minus 12 equals negative x plus y. So the first step is to find the x-intercept by setting y to 0. So then the equation becomes 2x minus 3 times 0 minus 12 equals negative x plus 0. And then you can just take away the zeros, and you get 2x minus 12 equals negative x. So then after that, I added 12 to both sides to get 2x equals negative x plus 12, and then added x to both sides to get 3x equals 12, and then divided by 3. So then x equals 4, and the coordinates of the x-intercept are 4, 0. And then they also want the y-intercept, so you do the same thing, but you set x to 0 instead of y. So then you get 2 times 0 minus 3y minus 12 equals 0 plus y. And then you take away the zeros and you get negative 3y minus 12 equals y. Then you add 3y to both sides. And then you get 4y equals negative 12 divided by 4. So then y equals negative 3. So the x-intercept is 0, negative 3. And then the answers are 4 and negative 3.
Any other questions on number 14? Julian, you did an awesome job. Thanks for doing the first one. Questions for Julian? And I will keep that paper. So I have everything like this. Thanks, John. Very nice. Julian, how was it on a scale of 1 to 10? Super hard to get up there? No? Awesome. Excellent. Good job. Alright, so Mackenzie? No, Mackenzie. Mackenzie's gonna give it a shot here.
So for this question, they just said, graph the equation, so it was in standard form. So I added 4 to both sides so that it would be in standard form. And then I did the x and y intercept to get it both to 0. So for the x-intercept, I did 3x plus 7 times 0 equals 4 to get rid of that 7. And then I got 3x equals 4, and then the x would be 4 over 3, so it would be the x-intercept would be 4 over 3, 0. And then for the y-intercept, to get rid of the 3, I did 3 times 0, so I would be 7y equals 4, and then the y-intercept is 4 over 7, so I got 0, and it's 4 over 7.
Any questions on number 26? Nice explanation. How was it? Not too bad? Not too- You have one done now, right? Yeah. Alright. So I'm going to talk about one of the paired word problems. Like another minute to get through.
So I wanted to talk about the one-word problem with the linear depreciation, which was 28 and 29. So if you can look at that set of both sets of problems. So a business purchased a piece of equipment for $500,000. The value, which is a V, of the equipment after 2 years is represented by this equation. So we have 3 times V, the value of the equipment, equals 225,000 T, which is equal to, or plus 225,000 T, which is equal to 1,500,000. First part says find the intercepts of the model. What does the T-intercept represent? So I know they give you that extra 500,000 in the problem, but like describing things, you don't really need to use that in the equation anywhere. You'll see that that number actually pops up. But if you're finding the intercepts of the model, this one doesn't have x and y. We have the v and the t because it represents pieces of an equation or pieces of a real-life problem. So when you have real-life applications, we usually don't use x and y. We use different letters to represent those applications. So if we want to find the v-intercept and the t-intercept instead of x and y, what would we do, Abby, to find the v-intercept?
You have to substitute 0 for t.
Yeah, so we're going to let the t be 0, so 3 times v, 250,000 times 0, and then 1,500,000. Should have left extra space here. Move this guy over. And when you do that, Abby, what do you get?
V equals 1,500,000.
And v is
500,000.
500,000. Let's talk about money here since it's a value. Okay, so the v-intercept we know is 500,000, comma 0. And then finding the t-intercept would be doing the exact opposite. So we'd be plugging a 0 in for the v. So we would have 3 times 0 plus 250,000 is equal to 1,500,000. I think I forgot my little t here. Which is really 250,000, which is equal to 1,500,000. So Abby, what's the t in that case?
6.
Okay, so for question 28, it says find the intercepts of the model. So we have 500,000 comma 0 and 6 comma 0. And then the second part says what does the t-intercept represent? What is the t talking about? If we find t equals 6, what does that mean? What does it represent with this problem? Number of years. And what happens in 6 years? Do you know what's happening in 6 years? Not quite. I'm going to check. Odette? Yeah. So that's what that number means because you're putting a V, you're making it equal to 0. So you're saying the value of the equipment is now $0. It's worth nothing. How long will it take for it to be worth nothing? And it'll take 6 years for the value of the equipment to not be worth anything. That's why this is called depreciation. When things depreciate, their value declines. What else would depreciate? So a piece of equipment, after you buy it, the value of it goes down. What else, like the value of something that we could buy? It would depreciate, it would go down after a number of years. Hunter? A pencil? Why would that decline?
Because if you're using a wood pencil, you have to sharpen.
Yeah, you gotta sharpen it, so it's gonna decline. The size of it gets smaller and smaller and smaller, and eventually you can't really use it anymore. 9th graders and 10th graders, you all have iPads. Those iPads, the value of it, they probably purchased them for, I don't know, $600–700. Mine I know is 5. This might be my 6th school year that I'm using it. If I wanted to try and sell it, probably wouldn't be worth very much. Cars, any car that you have, you buy it for $30,000, you drive it off the lot a month later, maybe you could sell it for $25,000 kind of thing. So lots of things in the world depreciate, they decline. Houses increase, usually they appreciate. So if you buy a house, usually that value goes up, where most other things go down. So that was number 28. We have the intercepts. The t-intercept represents the number of years. The v would be the value. So the value of the initial year when we buy it is the $500,000. The value when it's 0 is after 6 years. And then number 29 says find the slope of the model. What does the slope represent? So these are really good questions because you're not just like plugging and chugging numbers, but you're interpreting things. What are the meaning of these numbers that you find? So if we try and find the slope, Julia, what do we have to do to find the slope?
You're gonna first have to get v by itself, like it happens a lot.
So she said the v is acting as the y. Does anybody else know, like what you would try and be thinking about? Odette? So we want to try and find the slope-intercept form. And I think that's kind of what she was saying over there, where we want to kind of solve for the problem. And how would you find that slope-intercept form?
You divide 3v by 3, and you also divide 250,000 t by 3.
Okay, so we're going to eventually divide everything by 3, but let's take this number to the other side first. And then we'll divide each of them by 3. So then we have slope-intercept form. So we have negative 250,000 over 3. And then this one is the 500,000. So right here is this y-intercept. That was the initial piece of the equipment. That $500,000 is the starting value of the equipment. It appears in slope-intercept form. And then the slope of the model says negative 250,000 divided by 3. So this is the b. Right here is my slope. Julia, do you know what that slope means? It's decreasing, yeah. So the slope's saying that the value is decreasing. You could say that it's decreasing $250,000 every 3 years, because this number down here represents years. So money per time. Slope is a ratio. It's one thing compared to another thing. So it's negative. The negative means that the amount of money is going down over time. So anything to that effect, but make sure you kind of have something to show that it's negative, therefore it's a decreasing amount of money. Your money's decreasing over a specific amount of time. Any questions? Are there any other questions that you had? I know a lot of you were talking about that problem at the beginning of homeroom too. So that's a good problem because you're doing the math, but you're also explaining the math, explaining what does it mean with relationship to the problem. So today we are continuing this little review of lines. So we talked about functions, evaluating functions, finding the slope, graphing lines, and today we're going to talk about writing equations of lines. Tomorrow we'll kind of wrap up writing equations of lines and do a quick little review, and then you'll have a quiz on Friday. And that quiz on Friday would be on sections 2.1 through 2.4. So all of that material that we just talked about, functions, slope, graphing lines, and then writing equations of lines. So we'll kind of wrap this section up tomorrow and do a short review for your quiz. So when you're writing equations of lines, there are actually 2 different forms that we can use. And the one we just talked about was called slope-intercept form. But there's actually another form of a line that we you can write an equation with that is not commonly used, but I think it's actually easier to use than slope-intercept form when you're writing an equation of a line. And that's called point-slope form. So there's slope-intercept form, y equals mx plus b, but then there's this other form of a line, and it's called point-slope form. So the way the problem is set up enables you to use it if you have a point and you have a slope. So if I'm given a point, I'm given a slope, then it makes it really easy to write an equation of a line. Does anybody know, I guess you can look down below here, the point-slope form, it's given below. So we'll say another way to represent a linear equation So this works when you're given a point, x1, y1. So point slope form says y, which is just your regular y value, your y and your x, just those regular two variables that we use, minus y1. That y1 represents one piece of the point of the line they give us, which is equal to m, our slope, and then x minus x1. So the x1 and the y1 are the point that they give us. The m still represents the slope. Underneath, it tells us a couple of things about writing the equation of a line, because we're going to try and look at 3 different ways to write equations of lines, or 3 different kind of processes we're going to use. So the first thing says, if you are given a slope and a y-intercept, so they give you the slope, they give you the y-intercept. If you want to write an equation of a line, you should use y equals mx plus b for it. Because you have the slope, you have the y-intercept, you don't need to do anything special with it, you're just plugging them in. When you're given a slope and a point, we're going to try and get you to use this point-slope form. Some of you probably still won't like it, others will say, hey, this was a lot easier than I thought, and it actually makes a lot of sense. So point-slope form, if you have a slope and a point, we're going to try and use that form. The last option, or case that we're going to look at, is just when you're given 2 sets of points. So this would be like a little chart as to what information are you given, how do you approach the problem. And if you're given 2 points, it says first use the slope formula to find m. Because if you don't know the slope, we can't create an equation of a line without having the slope. So we'll find the slope first, and then after we have the slope, it says then use point-slope form with either given point. So it's kind of like a 2-step process when you're given a set of points. First you have to find the slope, then you have to use point-slope form with either point so that we can get an equation of a line. So we're going to talk about each piece here. If you're given this information, how would you find an equation of a line? So there's 3 different ways we can find equations of lines based off of the information that you're given. And if you look at the first set of examples here, it says write an equation given the slope and the y-intercept. So this would be case 1. Really straightforward. They have the slope is 1/2, the b value is 5. How could you write an equation of a line? What would it look like if the slope is 1/2 and the b value, the y-intercept, is 5?
Y equals 1/2 x plus 5.
Yeah, that's it. 1/2 x plus 5. So mx plus b. You have an m, you have a b, literally, you plug them in. There's nothing else you have to do. So part B, Mackenzie-Myers, we have a slope of -3/2 and a b value of -2. What would that look like?
Bro, y equals -3 takes x minus 2.
Yep, that's it. You don't need to have a plus minus there, plus a -2. Just -3, 8x, and then -2. Now the third one, we have a picture here, and the y-intercept is labeled for us. So if it's a y-intercept, that's the b value. Graph crosses the y-axis at the y-intercept. How can you find the slope by using the picture? So she said find 2 points in the graph and use rise over run. Where would another point on the graph be located? Yeah, so 2, negative 2. So you want to find another point on the graph where the line crosses through the corner of the box. And then she said use rise over run. And you can just do a visual thing. You don't actually have to calculate. So rise would be moving up and down. This time we're moving down. Starting at the left, you move to the right. And then run is moving to the right. So Emma, what would you say the slope is for this graph? Good, negative 3 because we're moving down 3. The run is left or right, and that's 2. So negative 3 halves. So the y-intercept is where the graph crosses the y-axis. That crosses the y-axis at 0, 1. And then the slope is your rise over run, the movement of the graph. So get 2 points, see how it moves from one point to the next. And then Emma, if we plug this into slope-intercept form, the equation would look like? So the slope and then the y-intercept is 1. Questions? So if you have a graph, you're finding the y-intercept and the slope. If you've given the information, you're just plugging it right into slope-intercept form. Alright, so the next set of problems here give us a point and the slope. And we're going to try and use point-slope form to help us find the equation of the line. And just a reminder, it's y minus y1 is equal to the slope x minus x1. So I want you to see that like this actually is a pretty easy way to find an equation. Because they give you a slope, they give you a point. You're just plugging numbers into this formula. So for A, we have an equation of a line passing through the point 2, 1 and having a slope of 2. So the point they give you is that x1, y1. So Eden, what would that look like if we try and plug it into the point slope form?
Y minus 1 is 2 x minus.
So you're keeping the x and the y, the regular x and y stay in your equation. You're plugging in y1, we're plugging in slope, and we're plugging in x1. And then you need to simplify. So Eden, what would you do to simplify here?
Y minus 1 is 2 x minus.
Good. Distribute the 2 through, and then one step further to simplify it would be 2x. And then add the 1 to the other side to get minus 3. And that's it. So now we have an equation of a line using point slope form. Questions? So why don't you try letter B here, right? An equation of a line that passes through the point 8, negative 1, has a slope of negative 1/2. So you're plugging in the point and the slope, distributing, setting y by itself, getting y by itself. Anybody remember using point slope form? Not really, maybe a little. You would have like gone over it a little bit in Algebra 1. I think last year in geometry you probably used y equals mx plus b. It's what everybody reverts to. People forget about point slope form. Maggie, what do you have when you plug stuff in?
Y plus 4 equals negative 1/2 x.
So negative 1/2 and negative 8 make? And then when we take the negative 1 to the other side, we would subtract it and get a positive 3. So y equals negative 1/2 x and then plus 3. So that's point slope form. You have a point, you have a slope, you plug them in to get the equation of a line. Any questions? Alright, so part 3, because there were 3 different pieces in that box, 3 different ways that we can kind of approach a problem depending on what information you're given. So this one says write an equation of a line that passes through 2 points. So we don't have a slope, we just have 2 points up here. And the first one is -8 and 20, and the second point is -6 and 15. How do you start writing an equation of a line when you're given a set of points? Melanie?
Find the slope.
Yeah, we need to find the slope. Melanie, do you remember what the slope formula is from a couple days ago?
Y2 minus y1 over x2 minus
Nice. So part 1, the first thing we need to do is find the slope, because right now we just have a given point, set of points here. So she said y2, y1, so 15 minus 20, x2, and x1. -6 minus a -8. That turns into a plus. So we have 15 minus 20, which is, and on the bottom, -6 plus 8. So our slope is -5 over 2. Okay, so we got the slope. What else do we have to do once we have the slope? Yeah, we gotta find the y-intercept. Because you need a slope and a y-intercept to have an equation of a line. So you can do the problem exactly like we just did the last 2, but you're just picking a point to use. You're not using both. So whichever one looks better to you. Maybe you like the second one because the numbers are smaller. Or you just want to use the first one because 20 is a nice number to use. But you need to pick a set of points, one pair, and use them either in slope-intercept form or in point-slope form. So I'm going to use point-slope form because my goal is trying to get you to use that a little bit more here. So we know the slope is -5/2. You need to pick a point, one of those pairs of numbers, and plug them in. And it doesn't matter which pair you use. So Maddie, which set would you like to use? -820 or -615? -820? So the 20 is y. The -8 is x. So this turns into a +8 because it's minus -8. So y minus 20 equals -5/2 x. And then you're taking -5/2 times 8. And I heard all those calculators come out. When you're multiplying fractions, remember you multiply top, you divide by the bottom. So we have -5 times 8. Maddie, what is -5 times 8? And then divided by 2. 20. Definitely doable without a calculator. And try and not get you to automatically reach for that calculator this year. So 5/2 times 8, this should be a minus, that's my fault. A minus 20. There we go. Alright, Julian, what else do you have to do to solve this?
You have to add 20 to the side.
Yeah, what happens when you add 20?
It just might go away.
Yeah, so we take this 20 to the other side, they go away, and you're just left with -5/2 times x. So the y-intercept is 0. It ends up canceling out. Questions? Alright, so let's see if we can do that exact same process again. This time you got some decimals, okay, you might want to take out that calculator. So the first step is to find the slope. anybody have the slope calculated? Jillian, what do you have?
Negative 3.5 over 2.8, which is
Okay, so he said negative 3.5 over positive 2.8, and then you trail off. That would be negative
negative 1.25.
1.25. So because you have a decimal divided by a decimal, actually like calculate that, do the division. Don't just leave decimals and divide it by decimal and a fraction. So now we have the slope, part 2. Take one of those pairs of numbers, plug them into the point slope form. So y minus, I'll just use the first one again, 0.9, that's my y2. The slope, negative 1.25, x minus 0.6. So I'm just using the first pair of numbers, that first point. What is negative 1.25 times negative 0.6? Julia?
0.75.
0.75? Okay. And then the last thing, we have to add 0.9. And Julian, when you add 0.9, you get negative 1.25.
Plus 1.65.
Any questions? So we wrote an equation using slope-intercept form when you're given the slope and the y-intercept. We wrote an equation when you're given the slope and a point with point-slope form. And now we're writing an equation by finding the slope first and then using one of those points and point-slope form to finish the equation because we were given two ordered pairs. So the last thing we're going to look at today will be what happens if we have parallel and perpendicular lines. So if you look at those, a little bit of geometry from last year. We're not proving shapes, but we can still think about lines being parallel, lines being perpendicular. This question actually has two parts to it. It wants us to write an equation of a line that passes through a point. That point is negative 1, 1. And then it says is parallel to and perpendicular to a line that we already have, and that line is negative 2/3 x plus 3. So I just flipped mine up here because we have to do two parts here. So we'll look at the parallel side, or the parallel line, and then we'll look at the perpendicular one. And we have a point of negative 1, 1. We have a current line of negative 2x plus 3. So if you're writing an equation of a line, you need a point. What else do you need besides a point? Odette? We need the slope. So we have to find the slope. We already have a point. Odette, do you know how we can find the slope if they give you a line?
It's for the parallel to be the same slope.
Right, so parallel lines have the same slope. Well, here's the slope of our first line. I already got this line. It has a negative, let's go this way, negative 2 slope. So my new equation, or my new line, is also going to have a negative 2 for the slope. So if they give you a new line, or if I want to find a new line, I can use the slope of the old one to help us do that. And again, we have a point of negative 1, 1. So we're going to help create a new slope by using the old line that they gave us. Parallel means the slope should be exactly the same. Now you have a slope and a point. Plug it in to find the equation of a line, just like we did the last couple of times. So y minus y1, slope is negative 2, x minus x1 would become a positive 1. So the only piece that we're using from the old line is the slope. We're not using the y-intercept because we want to find a new y-intercept. And simplifying this here, would give us negative 2x minus 1. So these two lines are parallel. They have the same slope, they just have a different y-intercept because they're different lines. Looking right next to it, we have perpendicular. So parallel meant the same slope. Odette, what did we say about perpendicular?
They have the opposite.
Right, opposite reciprocal. So if the slope is negative 2 of our given line, what's the opposite reciprocal of negative 2? Gavin? Positive 1/2. Nice job. We're still using the same point, negative 1, 1. So we have to find a perpendicular slope. This slope is perpendicular. So you're taking the given line, you're finding a perpendicular slope, and then you're plugging in the same numbers. Y minus y1, now it's 1/2 x plus 1. So as a fraction, not a mixed number, what's 1 plus 1/2? 3/2. Questions? So this time the slope is different because I wanted a perpendicular slope, so it should be opposite reciprocal with the line making close. So your homework tonight is in the book. It's also in the book tomorrow, so the next 2 days we've got some book homework. It's 1 to 29 odd on pages 101 and 103. Remember, that assignment is posted to Remind, also Google Classroom, and it's on the board back there. How about a volunteer to try number 17? And then somebody else for 23. So we had 2 nice jobs today. These are problems that you can kind of tick off that you don't have to do them. Emma, you'll try 17? And Connor, you want to try 23? Awesome, thank you. So we'll wrap up the